Hey, WDC House!
Hey!
Hello! Everyone, take your seats. This is going to be an awesome afternoon of pitches. I welcome you all to the WDC House. Some of you I have seen around, some of you are new. WDC House is sponsored by the District of Columbia and the Washington, D.C. Economic Partnership. We're here to promote D.C. as the capital of inclusive innovation, but also the mobility innovation capital. And while much of our work really has focused on mobility innovation, how we get around our city, how we get from block to block, I think it's really appropriate that we have NASA here who is thinking about mobility on a slightly different scale. But we are so happy to host them, or to have them in DC. So today we have an amazing panel of experts as well as 10 startup companies who are here to give lightning fast pitches around the NASA iTech work. And so with that, and to give you more information, I'm happy to introduce Kira Blackwell from NASA iTech to kick off today's afternoon event. Thank you.
Thank you. So, coming from NASA, we have a few rules. One, when the entrepreneurs are up here on stage, how many in the audience have been an entrepreneur before? Okay, a few of you guys. So those of you who haven't, the people who are going to stand on stage, it's very, very difficult for them. So when they come up, just give them your attention because they're scared to death to be here in front of this panel of judges and give their pitch, but they've got amazing technologies. And so that's sort of my one rule. Is if you can just respect their time, they've only got 3 minutes. And if people can't hear them or the judges can't hear them, then that creates a problem for them because it is a competition. So I'd appreciate that. Thank you. 2, what is NASA iTech? Thank you. So NASA iTech was started to search for technologies that are being developed really external to NASA because there's a lot of startup companies out there developing technologies that are changing the world. And we know that we can't solve all those problems ourselves. So we search for these technologies that have a commercial market application that are not currently already funded by the government. And that also can be a potential solution for NASA in solving one of our gaps in space. And so through that, I'm going to show you a video, I think. Okay, I'm going to show you a video that'll just highlight some of the technologies just so that you can get a glimpse of the kind of technologies that we see at NASA iTech. NASA iTech is a program that we have within the Space Technology Mission Directorate Office that searches for cutting-edge technologies that are solving problems on Earth that also have the potential to be a solution for NASA and the space industry.
What's unique about the NASA iTech program is that it operates in profoundly different, less traditional ways. They send out a technology call for applications to address specific NASA needs.
We have our subject matter experts, our chief technologists, provide endorsement, and with that, work hand in hand with the investors that are there.
Entrepreneurs need courage to do what they do. They need to have quite a bit of endurance to be able to withstand the pressures of being an entrepreneur. And they really need an ecosystem in their surroundings to help them move that technology forward.
Normally when you submit a proposal, you're never going to get the opportunity that you get to sit down with our chief technologist across our agency. And that's critical. It's critical for the entrepreneurs.
And the great thing just from sitting at the NASA iTech was looking at how some of these technologies, even though they were geared for space, some of the technologies could be repurposed for different scientific challenges in the environment, in space, and medicine.
How much better than having the CTO of a NASA center sitting with me talking to that technology?
The access and really collaboration that we get as finalists has been incredibly helpful and creates an opportunity for us to solve problems.
The beauty of it is those discussions are coming back with literally the technologists and the experts right now in the industry.
We are building a network of data relay satellites that can help remote sensing satellites get more data to the ground and reduce latency.
Where your Roomba and your drone have a kid, and the kid can disinfect the space station.
Our system can process wastewater just like it does in the body and urine, so that you get clean, deliverable water to a community on the ground.
Our team has developed a suite of patent-pending miniature robots that fit inside the pathways of the body.
We provide lifelike motion for the next generation of robotics and automation.
And I'm here to tell you about our needle-free jet injection technology.
It's an exercise machine that grabs intelligent data from astronauts in a microgravity environment.
We have designed a small, compact, lightweight apparatus for high-contrast imaging of dim exoplanets next to bright stars.
NASA iTech is reaching out to identify cutting-edge technologies that do have a commercial market value, but also can be customized to work within the space agency. We all benefit from that.
So that just gives you a glimpse of some of the technologies that have come through NASA iTech. The way that we designed it is we tried to set it up sort of like you would with an accelerator or incubator by reducing any of the barriers, minimizing the paperwork. It's a 5-page white paper. We made it simple, and we don't award prize money. I know that's kind of shocking. We don't award prize money, but those are some of our focus areas for this particular cycle. We have 2 a year, and so if you look at those particular focus areas, I'm sure you can envision some of those focus areas also apply to things that are being developed on Earth. And so since we don't award prize money, you might be wondering, well, has it been effective? NASA's not giving funding. Let's see if it has. Okay, so I believe the numbers. In the last 24 months, we've received over 500 different applications, and the 50 finalists that have participated have raised over $368 million of private investment dollars. 24 months, 50 companies, $368 million of private investment dollars. And those numbers are validated every 6 months. So that was done probably 4 months ago. And I would love to say that, you know, it was all me, but it's not. It's actually something like this. These panel of judges make a difference in their evaluations of those technologies. NASA's Center Chief Technologists evaluating it for a space application. But we also have serial entrepreneurs, investors, or subject matter experts external to the agency that volunteer their time to do evaluations of the proposals when they first come in for a commercial market application. So all the technologies that come in or that have met the sort of requirements of the top 50 have to have a commercial market application and the potential for a solution for NASA. And so in order to make it into those top 10, they have to meet both those requirements. I can't be your only customer because I'm not giving you funding. But I would like to be a potential future customer where maybe I could possibly buy the technology off the shelf like we do an iPad and modify it for our space environment, rather than NASA having to do all the early R&D stage work. So that's really significant for us. And apparently it's working with startup companies. So what I'd like to do next is I'm going to allow the judges a little bit of time to go through and each one introduce themselves so that you can actually grasp why the entrepreneurs might be a little bit nervous. They do get a list of these entrepreneurs, but I'm not sure I would want one of my technologies vetted by our chief technologist. I might be a little afraid too. They're a little bit tough. So I'm going to start down here, Richard, at this end. You guys can pass him that mic. And then if you can just do a quick intro so that you guys know who is sitting at this table, and I'll pass it off to you, Richard.
Hi, I'm Dr. Richard Manassi. I am the director of the Tampa Bay Wave Accelerator. I'm also a serial entrepreneur.
Hi, Dr. Ramona Travis. I'm the chief technologist at the Stennis Space Center, the nation's largest rocket engine test complex.
Woo-woo!
Good afternoon. My name is Peter Hughes. I'm the Center Chief Technologist for NASA's Goddard Space Flight Center. I came to the agency 34 years ago to do research in artificial intelligence and helping make decisions on a daily basis what technologies to invest in to be able to advance to the moon, Mars, and beyond.
Hello, my name is Shay Faring. I'm Vice President of Mission Assurance at Firefly Aerospace. We're a local rocket company just north of Austin, and hopefully in the next year or so you'll see us in the news doing our first flight for the U.S. government, both NASA and the Air Force.
Hi, my name is Rich Godwin. I am one of the founders of Space Technology Holdings, which is a space technology incubator, and also one of the founders and venture partners in Starbridge Venture Capital Fund, which invests in space-related technologies.
My name is John Dankinich, and I'm the Chief Technologist from NASA Marshall Space Flight Center, where we focus on advanced manufacturing, life support, and launch systems. And I help take small business ideas and innovations and transition those to commercial applications and also for future NASA programs and projects.
Good afternoon, Antonio Campello. I'm President and CEO of Embraer X, which is an Embraer company dedicated to develop disruptive businesses. I have a background leading teams ranging from engineering to product development, strategy, and business development.
Hello, my name is Michelle Hintz. I'm with Booz Allen Hamilton. I lead our Army Innovation Group, and we develop cyber engineering and analytics solutions for our U.S. Army and Department of Defense clients.
Sorry, we're going to skip one of the judges for a second because she has a really big announcement. So go ahead, Harry.
Hello, I'm Harry Partridge. I'm the Chief Technologist at NASA Ames Research Center. Thank you.
I'm Jay Harrison. I'm the Command Innovation Officer at the Army Futures Command.
And I guess last but not least.
Last but not least, but the entrepreneurs might want to pay attention to this announcement.
So I'm Kara Snesko from the U.S. Department of State, and I'm the coordinator for the Global Entrepreneurship Summit this year. We're partnering with the government of the Netherlands to put on the 9th Global Entrepreneurship Summit, connecting 1,200 entrepreneurs from around the world with investors and policymakers. The Global Entrepreneurship Summit will take place in The Hague in June. It is the only invitation-only event of its kind. And we are having an event at 5 o'clock today at the Dutch New Wave, which is their house over on 6th Street, to talk all about GES and connect with entrepreneurs and investors. And the White House Deputy Chief Technology Officer Michael Kratzios will be there. So you are all welcome to come, and you can follow us on Twitter and Facebook and find out more. But my exciting announcement is that the winner of the NASA iTech pitch today will receive an all-expenses-paid trip to the Global Entrepreneurship Summit.
Did you guys hear that? I asked if I could fit in one of their suitcases or something. I would assist them. No, just kidding. So you can understand why the entrepreneurs might be a little bit nervous giving their pitch, but if we could just give all the judges one more round of applause for just volunteering their time here, that would be great. Thank you, guys. And so with that, I'm going to gracefully bow out. I'm going to allow the entrepreneurs, the first entrepreneur to come on stage. They have 3 minutes to pitch. There will be, if they go over their 3 minutes, you will hear no one's back there to play it, the shark sound. No? Oh. The Jaws sound. Who's familiar with the movie? If they go over their 3 minutes. And so they will introduce themselves on stage. We'll give the judges about 30 seconds to actually tally their score for each entrepreneur. After that, there will be a 15-minute Q&A for all the entrepreneurs. We'll bring them all back on stage, and then all the judges will have an opportunity to do their Q&A. They'll go off and judge, and then we'll select a winner. So thank you guys for being here today, and good luck.
Thank you, Kira. Good afternoon, everybody.
How many of you have had this experience? You go to work on a piece of machinery like a motorcycle or a car, and like me, you get frustrated by how many tools it takes because of all the different kinds of fasteners. Well, when this happened to me, I decided that there must be a more simple solution to this problem of assembling machinery. So I invented UDOT, which eliminates all the fasteners and all the tools and all the wires and all the cables. Now, I'm Doug Sohn, and I'm the CEO and co-founder of Sohn Systems and the co-inventor, along with my wife Sherry, of UDOT, which is our patented technology. Here today with me is Eric Shear, who is our chief spacecraft engineer. He has a master's degree in Earth and Space Science and is a two-time iTech semifinalist. Our other team members are Jesse Cohen, mechanical engineer, and Steve Cedio, electrical engineer, both with decades of product development experience. Now, I know we've been using nuts and bolts and screws to build things for hundreds of years, and we've been using them to build spacecraft and rockets for decades. But the number and types of these kinds of fasteners has only proliferated over the years to the point where it takes a toolbox the size of a large Foot Locker to run the ISS. Now, that all adds up to time out of service, labor time, labor cost, cost of tools, and cost of fasteners, and the potential for foreign object damage. Now, all that worked okay in the old days, but we're told this is Space 2.0, and that means that there are companies like Firefly Aerospace, who are young companies, agile companies, flexible companies, and cost-conscious companies. And this is the perfect environment for the UDOT Quick Connect spacecraft system. Now, what is UDOT? UDOT is an interlocking system of dot-shaped features and U-shaped features that slide into each other and can only be disconnected by sliding in one direction, and that's blocked by a locking bar that locks it into place. And the system also includes the power and the data circuitry, so you don't require tools, wires, or fasteners. So if you install our UDOT panels in the inside of any spacecraft, then you can take any UDOT module, slide it into place wherever you want, and it's immediately locked into place, tied into power and data without the use of any tools or any fasteners. So you can do the initial configuration of your spacecraft with this. You can reconfigure it very quickly for new missions. You can even do repairs. All this gives us a distinct advantage over the traditional manufacturers of fasteners and components. In addition, because UDOT provides for a universal metric, it will form the basis for an entire universe of standardized modular components, an entire modular system. It'll be as revolutionary as when Henry Ford introduced the concept of standardized parts and the assembly line to the automotive industry. And think about the applications to smart homes, to workspaces, to education, to hospitals of this kind of embedded technology. Now, our business plan is to license this technology to aerospace and spacecraft and other manufacturers. Right now, we're starting on our product market fit research, and so what we're asking for today is introductions to and conversations with the designers and engineers of spacecraft. So, welcome to the future of spacecraft design, the UDOT Quick Connect spacecraft system. Thank you.
It is easy to overlook the things that connect our lives, which are the mundane things around us. If you look around, there are bolts and nuts literally everywhere. The Enduralock bolt and nut reimagines something very old, creates something new, and in the process will change an industry. I'm Dr. Harold Hess, CEO of Enduralock. I work with my team of co-founders and 4 engineers in the Kansas City area. The Enduralock fastener is the first permanently locking fastener that yet is reversible and reusable. It has withstood 1 million cycles of vibration, which is more than 30 times the aerospace requirement for a self-locking nut. We've also demonstrated reusability with up to 250 applications and removals. There is no competing product that provides for high vibration resistance, even with loss of preload or clamping force, with easy reversibility and reusability in a harsh environment. With our fastener, We have 2 machine flats on the bolt and the same on the washer. That prevents rotation of the washer. We have circumferential teeth along the inner rim of the washer. We have a titanium spring that has arms that snap onto the nut and teeth at the base. When these components mesh, it's permanently locked. A standard 6-point socket is applied, flexes the arms inward, disengages the teeth, the nut is free spinning. As soon as the socket is removed, it again permanently locks. There are numerous applications for Enduralock fasteners both in space as well as on Earth. A key attribute of our fastener is that it reduces the time and cost of installation and maintenance. We are establishing new national aerospace standards with sponsorship from Bell Helicopter and Boeing Helicopter. Gulfstream Aerospace is creating their own internal standard to replace castle nuts and cotter pins across their fleet with our fasteners. We have supplied product to 2 oilfield services corporations, including components for high vibration resistant 20,000 psi nitrogen fittings. A launch vehicle with its payload, such as a satellite, endures tremendous vibration. Well, Enduralock fasteners were designed for high vibration environments. The easy reversibility and reusability of our fasteners make them ideal for construction in space where structures might need to be repurposed. These attributes also make them ideal for reusable launch vehicles, such as in attachment of heat shields. Whether it's for the warfighter, the pilot, or the astronaut, the reliability and safety of our fasteners that our fasteners provide is our utmost priority. Nuts, bolts, washers are used literally everywhere, so the scalability of Enduralock fasteners in multiple industrial verticals is almost limitless. Looking again at the mundane things around us, when is a nut and a bolt not a nut and a bolt? When your life depends on it. Thank you.
Hello, Austin, esteemed judges. My name's Hunter. I'm founder and CEO of Ubiquity, and we're using nanotechnology to make plants grow faster, which is addressing a major issue in the indoor cultivation industry, that is the low and declining profitability of growing plants using artificial lighting. And this is driving cultivators increasingly into greenhouses, already at 54 billion square feet globally, where they can dial in every aspect of the growth, but not the light because it's a greenhouse and it's using sunlight. And sunlight varies by season, location, and if you're going into space, you can imagine it varies even more. And so our solution passively shifts the colors of sunlight using advanced material called quantum dots, a material that glows. So I've got a sheet of glass here. Hopefully you guys can see that it's kind of just glowing even in these lights. I can show you in person a little bit more closely, but basically it's giving plants that color of light that they like the most and drives photosynthesis most efficiently. So you get higher crop yields, better crop quality, and in some cases faster cycle time. Our first product is a 4-foot wide retrofit film, so it's flexible, hence how I got into that category. And you can apply it in any existing greenhouse. We've been testing it on a number of different crops. Cucumbers and tomatoes, we've seen up to about 50% yield increase. And we recently started working with the University of Arizona to look at lettuce through the STTR program. And in space, we think that it would be even more effective because we're very effective at converting ultraviolet light. So we can take that spectrum that you get without an atmosphere and make it not only more like plants are used to here on Earth, but is really dialed in for the optimal growth. And media's been taking notice. We've been featured at phys.org, Forbes magazine, CNE News, places like that. It's a really exciting time for us. Our traction is really accelerating. We've got granted patents, very robust portfolio, including a license with Los Alamos National Laboratory, where I was a postdoc after I finished my PhD, but also MIT, University of Washington. We've also got capital that we've raised. We've raised about $2.5 million. We have revenue. We have Peter Thiel on our cap table through a program called Breakout Labs. And we have grants from National Science Foundation, for example, DOE, and others. But I can't take the credit because my team rocks. We check all the boxes. We've got PhDs, MBAs, exit experience, cultivation experience. Ask me in the Q&A, I can tell you more about the team. Product pipeline is pretty straightforward, initially addressing the $3 billion greenhouse film industry. Then we'll approach a much larger opportunity with glass because we can go beyond just greenhouses with the glass product. And then we'll be able to optimize our value capture using our property. So if you're interested, come find me afterwards because we'd love to work together with you to improve grower profitability, both here on Earth and in space. Enable growers to get the most they can out of the sun using quantum dots and our first product called UbiGrow. Thank you.
Well, as a firefighter, I've seen way too many children have concussions and way too many people dying from heart attacks. My son has had a traumatic brain injury, and the FDA has never approved a device for concussion. My name is Stan Sansone, and our company, 911 Medical Devices, has patented and developed a cooling device to save the brain and extend survival. Our medical device, 911 Head, is a on-demand hypothermia helmet. It works to save the most life-critical organ, the human brain, anywhere. You could be on vacation, could be in the middle of the Iraqi desert, or perhaps hurling through space. So if you look at concussion, perhaps, concussion causes bleeding and swelling and spiking temperatures within the brain. By applying immediate hypothermia or cooling treatment, it could slow bleeding. It could stop swelling and reverse swelling. In fact, the treatment for intracranial swelling is to drill a hole in the skull. And finally, it stops spiking temperatures. Hypothermia that's been treated, been used for traumatic brain injury, has showed improvement of survival rates by 56% and 52% for improved outcomes 1 year after the injury. Heart attack is the leading cause of death worldwide. But the real death is from cerebral hypoxia. Your brain dies. So by applying a hypothermia treatment, it improves, it slows the metabolic rate of the brain, and it slows the activity of the brain. It also reduces the oxygen need for the brain. All of this to improve basic life support. Our markets are military, first responders, hospitals, and sports medicine. Thank you very much.
Good afternoon. My device is the Zero Gravity Handheld Surface Mount. It's a modular application for any tablet screen in the Kindle or iPad 12.9 and features a one-step mounting process. My name is Jeffrey Voorhees, and my company, Motion Mounts, was founded several years ago after my MP3 player kept falling on the chair, when it kept falling on the floor from the chair. So I developed a mount for drummers that goes onto a cymbal stand, and that was the genesis for this idea. There was success for several different companies in the music industry, including the teleprompters and software imaging, and distribution through outside distributors like Amazon and Guitar Center, until the iPad Air was released. New dimensions are no longer fit my model anymore. That discovery 4 years ago has brought me here today. Excuse me. It's a mount that fits all tablet sizes as well as an ergonomic feature. It's a simple, same mount, different mounting system. Method one is the surface mount. It attaches to anything with hook and loop material, including the protective shell of a tablet. In turn, it attaches to third-party accessories, including tripods and flex arms. Method 2, we see in the slide, and right here, it was what a problem I was having was the original clip design, I was constantly leaning in to read the tablet because it was anchored in the position, and tablets are meant to be held like a book. The tablet now releases for a handheld position, making the tablet less fatigued while hands, and why is that important? No, the tablet is no longer mounted for options. It rotates from portrait to landscape, which is the finger. It's easy hold and to be in place. The handheld solution is the handheld solution makes it easy and is great for people with difficulty holding objects with their hands. News, email, web texting, and other information are all within reach and in visual contact, not laying flat on the counter or on a sofa, making this the domestic solution for any tablet size. Other applications include, but are not limited to, the healthcare and customer service that require handheld use of a portable computer, and the Gravity handheld surface with a simple ergonomic, effective mounting system that will support any business workflow, as well as tasks being performed in space well into our future. This game-changing product addresses a problem with ergonomics and mounting a tablet securely in a one-step motion, creating infinite possibilities and communications and apps. Thank you.
According to World Health Organization, 70% of the deaths across the globe are because of unhealthy lifestyles, primarily coming from physical inactivity, stressful working conditions, imbalanced diet, and poor sleep patterns. Now add another dimension of microgravity to this, and you can imagine how much risk it poses to our astronauts' health in the space. Good afternoon, ladies and gentlemen. My name is Vinod. I'm a co-founder of Wellnesses, based in Atlanta and Bangalore. I have with me Dr. Pallavi, who is our principal scientist. We are a passionate team of 4 founders aspiring to create a culture of wellness into every individual's daily routine. So what we have developed is a revolutionary system for holistic wellness training and tracking using artificial intelligence. Unlike the traditional trackers that are available in the market, our system actually designs a custom program based on each individual's condition. It trains you, and then it tracks the progress. So the first product on this platform is based on yoga, hence the name Yogify. Now, why yoga? Research has proven that yoga techniques provide significant relief from various physical and psychological stress conditions. That's why we have close to 300 million yoga practitioners across the world today. Now, despite the known benefits, many find it difficult to integrate yoga into their daily life, primarily because of time constraints, busy lifestyles, lack of tools for remote practice, lack of consistent motivation, and so on and so forth. Now, Yogify aims to address all these challenges and many more using cutting-edge technologies. At the core of Yogify is an intelligent yoga mat that provides guided instructions, tracks your postures, provides real-time correctional feedback, tracks your body vitals and breathing patterns, and correlates everything to give a 360-degree view of your overall practice and its impact on your health. Now, how is this going to help the astronaut or the space industry? So now Yogify can be a perfect wellness companion, and a virtual yoga instructor for the astronauts. It can design a custom yoga program based on each astronaut's condition and the body vitals, and help them during their preparation, the space living, and the subsequent rehabilitation. It can guide them through the progress. It can track their progress as they are practicing, and it can help them stay fit throughout the space mission. Thank you.
Hi there. I'm Scott Edgar. I'm the CTO and co-founder of ErisMD. A little bit of background with me. I've been a software developer for many, many years now. Many of you out there in the crowd probably have an iPhone. If you have an iPhone and you use the keyboard on that phone, I did a lot of work in terms of the patents and stuff that drive that keyboard. So I want to talk to you today about our company, ErisMD. Medical error, and specifically avoidable medical mistakes, are the third leading cause of death in the United States, which is possibly the most medically advanced country in the world. Did you know that your heart, your lungs, my lungs, they're all in different places? We're as different on the inside as we are on the outside. I mean, this is pretty obvious if you think about it. I mean, you and I look very different. There's no way that our organs could be in the same places. And there's no way for doctors to really understand that easily at this point in time. So right now, when they look at medical imaging, be that CT, MRI, any of that sort of imaging, what they do is they look at it in slices. So they look at it like flipping through pictures in a picture book. And they try and composite those images in 3D in their mind. This is a huge burden on them. It requires a lot of training to do this. We take the images and put them in 3D so that they can view them organically. They can view them for diagnostics. They can view them for surgical planning, and using augmented reality, we can actually project those images on the patient so they can see them live during the procedure, so they can see exactly where something like a tumor is without actually having to cut into you. This allows procedures to be much safer, much faster, and much, much more effective. Now, I want to tell you a little story. My co-founder, Chandra, she actually had what was supposed to be an outpatient day surgery, and when they went in and they did this surgery, they actually nicked an artery because it wasn't quite where they expected it to be. And she actually ended up requiring a blood transfusion to save her life on what should have been a very easy in and out surgery. So this is a huge problem that affects everybody. We allow surgeons to use virtual reality, for example, or even a 2D screen to make a map that they can then follow in augmented reality to perform the surgery. It's like Google Maps for medicine. It allows surgeons to know exactly where they're going, what they're doing, where to cut, and most importantly, where not to cut. So at ErisMD, we're saving time and we're saving money, but in terms of patient care, most of all, what we're doing is saving lives. And what this means for people such as NASA, for example, with Ignite the Night, is that they can have somebody on a space station able to view these images being scanned with a handheld scanner and be able to understand exactly what's going on to make things safer in an environment where critical care is just not available. So thank you very much.
We have all experienced power outages here on Earth. What if we lose power in outer space? Unfortunately, there's no electricians to call in outer space. This is a risk our astronauts face when in space and here on Earth. How long will our energy resources last us? Can we make our energy resources last longer? Hello, my name is Ryan McAllister. I am the president at SCV Electric. We work with the electrical industry to solve our energy problems. My company is located in Santa Clarita, California, and we worked with the electrical industry for 20 years. I have invented a machine that generates electricity with 60% more efficiency. It is called a frictionless maglev generator. NASA is currently working with maglev technology for different applications located at the Ames Research Facility in Silicon Valley, California, with great success. The frictionless maglev generator works by levitating frictionless within a more efficient magnetic field, eliminating bearings and almost maintenance-free. It can retrofit into all of our existing electrical generating applications and can be used as a more efficient electrical motor or turbine. It can be built in different stages and efficiency. I'm losing the battery or something here, sorry. It could be built in different stages and efficiencies from warm maglev to superconducting maglev and placed in a vacuum enclosure. If we do not solve our energy problems, we will continue to be limited in space from exploration, colonization, and distances that take us years of time to reach and be reached much faster. Our Earth's natural energy resources are currently being depleted and getting more expensive, causing us even more energy problems we face today. Albert Einstein and Nikola Tesla explained to us about harnessing electrical and magnetic energy, and I think it's time to start listening to them. The frictionless maglev generator will not only save on our natural resources, but it will open doors to harness and generate electrical and magnetic energies.
Sing to the music. Okay. Astronaut Tim Peake had a monumental series of challenges when he did a spacewalk and was tasked to replace power regulators and install a complex cabling system. With an integrated AR and VR helmet, Tim would have shortened his 6-hour odyssey to save mission time, reduce human fatigue, and save millions of dollars. We are Jarvish. My name's Mark. This is Carol. Jarvish is inspired by Iron Man inventor Tony Stark. We come from Taiwan, where everyone owns a motorcycle, and we make smart helmets for the military, the emergency services, and everyday motorcyclists. Jarvish creates hands-free, wearable technology to maximize human-machine interaction. Motorcycle riders face constant, fast-changing information and planning challenges. Riders need to keep their eyes on the road, so information is presented to them in a high-resolution, non-intrusive head-up display that reads road signs, helps avoid obstacles, navigation, while voice control enables hands-free control of functions through Alexa, Siri, and Google. Motorcyclists and astronauts share many common problems, from safety and situational awareness to information access and human performance. Over to you, Carol.
We are developing a flexible and transparent AR piece to complement other features, including, first, a crystal clear and retractable head-up display for virtual imaging of AR and VR applications. Second, a rear view camera for 360-degree visibility. Third, a directional microphone for precise voice commands. Fourth, fast streaming for sharp video and clear audio. The helmet is powered by a non-explosive, low-energy, fast-charge battery. Voice control frees an astronaut's hands to increase productivity during space walks. Thanks to AR, users can see key information at a glance, like radiation, CO2, oxygen, and body temperature levels. Then quickly switch to VR to read a datasheet or instruction from an operation manual. With our AR head-up display, TeamPeak would have AR scale and VR directions, plus remote support, while his eyes open a technical manual or take a checklist via voice command.
If Tony Stark made helmets, he'd make a Jarvish helmet that would take mankind to Mars. Thank you.
Hello, everybody. I'm Catherine Forth, the CEO of Zebrio. Here's a scene from yesterday's world. Barbara, a grandmother of 4, has fallen again. This time, she's broken her hip. And 34% of people who break their hips actually die within a year. Here's a scene from a world with the Zebrio scale. Barbara wakes up, she steps on her Zebrio scale, she tests her balance and weight for the day. The scale alerts her she's in the danger zone for falling. Barbara goes to the doctor, and the doctor prescribes her rehab. A month later, Barbara hasn't fallen, and she's now scoring in the okay range for balance again. 1 in 4 older adults fall every year. It's the #1 leading cause of accidental death in that population, and it results in $50 billion in medical costs. The CDC says to reduce falls, you have to first screen for fall risk and then intervene. But the real problem is, how? There's currently no easy way to measure balance or fall risk. Until now, originally invented at NASA for astronauts on the moon, our technology uses artificial intelligence to measure balance and fall risk. You simply stand on the scale and you get a measure from 1 to 10. 10 is the best. 1, 2, or 3 means you're at high risk for falling. The Zebrio app then guides you through so that you can improve. So for Barbara, she can measure herself at home, in the gym, or in the doctor's office where it's reimbursable. And Barbara loves it because it works. When we left our scale in a senior living facility, it halved the number of falls from the year before. And so Barbara then knows this could actually save her life. Our team has been conducting groundbreaking research for over 15 years with a nice triangle of expertise with myself in balance physiology, my co-founder Eris from MIT and Harvard, who is big data and an applied mathematician, and our director Julian Nikolchev, who is a serial entrepreneur in medical devices with numerous exits. We also have a wealth of experience in our advisors and our clinical partners with UT Health and Memorial Hermann, and our commercial partners, Analog Devices and Procter & Gamble Ventures. So the time is now to help all the Barbaras in the world with NASA technology. We are launching here at South by Southwest so that you can pre-order your scales at 20% discount. We are Zebrio, the balance company. Thank you very much.
Hi, my question is for Hunter. Hunter, what's keeping you from putting your film on glass right now?
Film we can make roll to roll, and so we can make it at scale much more easily using a liquid resin than with glass, which is just challenging to do ourselves. So we're working on it. We got to work with a partner on glass, whereas film we can do it using contract manufacturing. It's a laminate with glass. With an inner layer is where we put the material.
Question for Harold. Do you use common tools for the locking system, or do you need specialized tools?
It's a standard 6-point socket off the shelf. So it requires no specialized tools at all, which cuts down on the time of maintenance.
Okay, thanks.
So great set of presentations across the board. Thank you very much. Eris, can you tell me how mature your technology is and how long it would take, do you think, to get this to market, to something you could do for our medical field?
Sorry, the question was how much is it?
How much would your target unit cost and how long would it take to get to market?
Well, so in radiology, the target market is about between 100 and 450,000 a license, a unit. Yeah. And how long? Sorry, it was the second. How long to get this to market? We're probably about 6 months out, depending on
Question for Ryan. I can't see him back there. Ryan, your maglev. Are you talking about like a flywheel suspended in a magnetic field that could store power on orbit?
It's similar. It's actually a generator rotor, and that takes place of like a high-speed train, and that actually the rotor levitates within the magnetic field.
But could you store electricity if you spun it? If you spun like a flywheel in your magnetic field, would it store kinetic energy?
It's not made to store, it's made to actually generate.
So for Ryan and for Catherine at the same time. So my question is the same for the two of you. So can you give more colors on the problem your product solves for the space, please? Just to explain better, how you're going to solve a problem that we have today in the space application.
Well, in space, we can implement it to generate electricity more efficiently and save whatever resources we're using right now in space. So if we're using solar, we can use solar to feed the generator. If we're using nuclear energy, we can use nuclear energy to turn the generator. Whatever type of resource we use, it can feed into the generator more efficiently.
Thank you.
And for us, as we already invented it at NASA, there is a NASA Tech paper on our technology. Really, it's trying to create this insight into understanding the astronaut's health. As you're doing longer and longer duration space travel, there's a greater effect on your neural sensory interactions as to how that comes through for the body and how you control your posture. And so this is something that then can be applied, maybe it's in the astronaut's home, that they can test themselves a little bit more frequently than the R+1, 3, 9, 15, et cetera, that maybe it's a little bit easier for them to be monitored, even though and then gain better insights as well, because the algorithm actually gives a more in-depth look to it. So it's really just trying to provide a tool, so reflecting it back into the astronaut core in terms of how can we maximize their health and really understand the impacts of microgravity on their body.
Okay, thank you.
Now, I had a similar question, Catherine, for you around the scale. That's okay, hard to see where I'm coming from here. I had a similar question around that. I mean, does zero gravity impact balance? Is that something that, the scale can account for as your, if it were to be used in that application?
Absolutely, and we have already used this on astronaut data, which is why it's a certified space technology. And the resolution is so high that the current technology that's being used, you have a measurement of balance, but it isn't predictive of falls. And so the sensitivity of this particular measurement is that we actually have that predictive capability. So it gives an even a more in-depth insight with respect to postural control. Does that change with microgravity? Absolutely does. So yes, you've got the muscle atrophy, but you've also got sensory motor degradation, which is a huge part. Your sensory systems are adapting to that microgravity environment, and you have to readapt back to the Earth's environment. And this is a tool to know exactly where you are. And is the training, is the retraining that you're doing, is it truly bringing you back to where you want to be?
My question is for Jarvish, sorry. Is this a prototype, or are you actually manufacturing these helmets and selling them in the market?
We have sold 5,000 smart helmets in Taiwan, but it's a low level and middle level without HUDs. And we had that one is a prototype. It will be manufacturing, shipping in this year, Q4. Yeah.
In the United States?
Yeah, in the United States.
And you know, an astronaut's helmet has very specific technology applied. So can your tech be applied to the existing helmet? Because clearly that helmet is for motorcycle riders. So can the tech be applicable to the existing design?
Yes, I think we could, because we have Taiwan government project for another kind helmet, not motorcycle. So it's for manufacturing or engineering side helmets. So I think we could do for astronaut helmets.
Okay.
Thank you.
Hello, Harold. Quick, what is the failure mechanism of the bolts?
Just as with any other nut and a bolt, it fails at the threads. The fact that we put the two flats on, machined, only goes down to the root of the thread. So in testing, after we did the vibration testing, we did tensile testing, they proved out to be what the requirement for aerospace requires.
Thank you. Jeffrey, what's the weight of the...
Of the not astronaut helmet, because we didn't. We haven't made it. For that prototype, we think it will be 1.4 kilogram. Yeah, it's with the electronic parts inside the helmet. It is also light. Yeah.
Okay, my last question was Doug. How does it? What weight will it hold, and how does it do under vibration?
Those are excellent questions. We're a bit far back from that point. Right now, we're still doing the product market fit research, so then we move into engineering and answering all those kinds of questions, so we have these conversations so we know, oh, look, here's the questions they're going to ask. Let's do the research and get those answers.
So this is for Ubiquity, 9/11, and maybe ARIS. What are the regulatory barriers to introducing your products to the commercial market, and have you guys started down that path?
Guess I can go first. That's one of the main problems that we're addressing with this technology, because in the past, quantum dots were composed of toxic heavy metals like cadmium or lead. The cadmium-free solution includes phosphorus, which is also toxic. So we have a copper and zinc-based material, so that's first. And actually, to go through to commercialization with the product, it's a new chemical, it's a nanomaterial, so we have to go through the TSCA regulation with the EPA. And we recently got approved through the what's called a low-volume exemption, but it's initial pre-manufacturing notice for commercial production, and that recently happened about maybe 6 months ago. So the product launched shortly after that, once we had the EPA approval to go for non-R&D purposes.
Hi. So for our part with ARIS, our product requires, it's considered a Class 2 medical device, so it requires an FDA 510K clearance. We are in the process of getting that clearance. Do you want to add?
So actually, it's the hardware that requires the clearance? Okay, well, but
The hardware does as well.
the hardware does as well. So a lot of them already have it, and because we're software agnostic to any of the hardware devices, some of that falls under them. So, but we're in process.
In 911 had the FDA is requiring 2 clinical trials, one for concussion and the other for cerebral hypoxia. And that's where we are right now. We're looking for funding to commence those clinical trials.
I have a question for Jarvish.
Thank you.
I'm not sure if you quite answered this when someone else asked about the adaptation of the helmet for astronaut use. Have you considered moisture accumulation, heat issues? We've been dealing with moisture issues with our astronaut helmets. So have you dealt with any of that and have a way to address that? Because you're in a closed environment in an astronaut suit.
Jarvish is pretty much a software company. So the chassis that you see is actually manufactured by a company called Shark. So the software can fit inside anything, but it's not been tested in the environments that you're looking at, you're talking about right now. But in the context of motorcycles, yes, it's been heavily tested for humidity, for leakage, for wet motorcyclist hands in all conditions. So from that context, yes, it has been tested for humidity, for dust, for moisture, for ingress. But in your context, no, of course it hasn't at the moment, because it would need to be fitted to the appropriate helmet and then tested.
Yeah, how that would interact with your electronics and the like.
Exactly, but at the moment we know in our environment it works fine. Oh, it's being used at the moment by the Taiwanese police force, and they use open face helmets. So actually, there's quite a lot of environmental issues that do get inside the helmets, and we've not had any problems that we had in the early days have all been overcome. So there's an ongoing live test, if you like.
Okay, that wow, we've never had the judges run out of questions before we ran out of time. So that's a first. Write that one down. So, right, you ran out of questions. So Jed is going to escort the judges to a conference room upstairs. And then while they do that, we have a really special speaker today that actually flew in. We have a very busy schedule at NASA today, and she is one of our senior leaders at the agency and within space technology. She's the Deputy Associate Administrator for Programs, and I'm going to give them a chance to walk that way. So my latest joke, no, I'm just kidding. I would be really bad at jokes. So if you guys could, as they're exiting, and then when we clear the stage, Teresa's going to come up. If you guys could help me welcome my boss, Therese, who really, there's a lot she missed today just to be here to help support this program. And so if you guys could help me give her a round of applause, just in appreciation for her time here today. Thank you, Therese.
Good afternoon. As Kira mentioned, so first of all, let's give another round of applause to all the people who came today and briefed us on their advanced technology applications that they're found uses for on this planet, and that hopefully we can find uses for out in outer space. So a round of applause for everyone for all the good work that they did in their briefings. I'll tell you, you don't want to be in the room with the judges. That's a group of really smart people who all think they're going to be fighting about things, so it's going to be interesting. As Kira said, I'm the Deputy Associate Administrator for Programs and the Space Technology Mission Director at NASA headquarters, which is a very long title that really just means I manage a whole bunch of space technologies. And South by Southwest, this is the first time I've been to this venue. It is amazing. And I was reading about how South by Southwest is really committed to helping innovators be able to achieve their goals. And that's very consistent with what we do at NASA. And so we've had a heritage at NASA in terms of trying to achieve really advanced, difficult things throughout our history, and it's always required innovation. And so the center that I was originally started working at was NASA Glenn Research Center in Cleveland, Ohio. And they were formed to, during World War II, it was determined that the nation that would win World War II would be the one that had the best performing aircraft. And what we had in the United States at the time were two engine companies that were very conservative in their advancements. in their investments, in their what we would probably refer to today as IRAD. And so neither engine company was interested in advancing their engines to be water cooled so that they could fly at higher altitudes, fly faster, and also not related to the engine, but be able to fly over the Himalayas without being iced up and lose control of the vehicles. So NASA Glenn Research Center started out as the Aircraft Engine Research Laboratory in Cleveland, Ohio. And the purpose was for rapid development of new engine systems that could operate with a water-cooled engine, higher performance, aircraft could fly faster and could fly at higher altitudes. And the nature of the work was driven by a political imperative, right? We were at war. And so NASA was really about how do we develop technologies so that we can get them into operation, so that we can apply them to the real political imperative and come out of World War II on top. Fast forwarding several years when we get into the space race, very similarly, a lot of advanced capabilities and a lot of innovations were necessary for us to accomplish as a nation, being able to get humans to the surface of the moon. And again, that was a political imperative. We were in a space race with who we considered to be our enemies in Russia. And so, again, rapid development with a focus on meeting a very difficult objective in what would be considered a very short period of time. Throughout history, when we've had these major political imperatives, budget was not an issue. And so here we are in 2019. I almost got that wrong. Here we are in 2019, and I would say that although it's not as obvious, there is still a political imperative for us as a nation to continue to, and as a world, in our partnerships across the world, to try to advance in what the things that NASA's major objectives are. And so, because we don't have the same budget associated with what was available during World War II in order to win World War II, we don't have the same budget that we had available to get to the moon with humans that we had in 1960s. We had to make kind of lemon out of lemonades, and we rely a great deal on outside capability and partnering with other nations and with industry and with academia. So within the Space Technology Mission Directorate, so NASA headquarters, NASA in general, has three major mission directorates. One is aeronautics, which I talked about, and we still are developing aeronautics technologies in order to meet some national objectives, including much lower emissions on the aircraft and in the airspace system. As we continue to increase the number of vehicles in the airspace system, how do we manage that from a cybersecurity perspective and be able to have autonomous decision making with large aircraft without having a human in the loop in every decision? And so a lot of that technology is necessary for aeronautics. And we do work very closely with industry on that. Our Science Mission Directorate has two grand challenges. We have a lot of missions in our Science Mission Directorate. We have the James Webb Space Telescope, where we're going to be able to use different bands of telescope light in order to see differently into the depths of the universe. But our two grand challenges in Science Mission is to find out as much as we can about the development of the universe, of the space systems. And the second is there another place we could go and live? Is there another planet that's Earth-like? And so there are a lot of advanced technologies necessary in order to achieve those grand challenges within that. Our human so there's aeronautics, space science. Human exploration is the third major mission directorate, and that's the one that a lot of you are addressing today with a lot of the medical issues. How do we get humans to another place in deep space and bring them back alive? And Human Exploration Mission Directorate is the one we're operating the space station right now. We're developing capability to go to the moon, Mars, and beyond. You might have seen today they rolled out the 2020 President's Budget Proposal. A lot of talk about what we're doing for the moons, Mars, and beyond. my mission directorate that I belong to, the Space Technology Mission Directorate, we support the Science Mission Directorate and the Human Exploration Mission Directorate's objectives by developing advanced technologies and architectures in advance of the time that they need them so that we can maybe change the game. How do we get there faster? How can we significantly change how we do missions so that we can do more with less, so that we can get there faster, so that the value of the mission is greater, so that we're able to do more with less. And within our mission directorate, we get to do the really cool stuff that could change the entire game. We support our space science mission directorate through propulsion systems, et cetera. The majority of what we're doing right now, because this is what this president's policymakers want, is how can we quickly get humans to the moon for a sustained period of time. And so we're developing technologies for cryogenic propellant storage so that we can develop different architectures that require a lot fewer launches. We are developing advanced electric propulsion systems and survivability ECLIS, environmental crew life support systems. I forget what it stood for. We talk in acronyms all the time. And so we're responsible for developing those advanced technologies, but almost everything we do is in partnership with either universities, industry, or small businesses. And so we have a portfolio of technologies in 2019 that are it's about a $927 million budget for FY19, which means between now and October 1st of 2019. And we develop technologies in the early stage, meaning low technology readiness level, in what we call tech maturation, which is in the middle technology readiness level, and in tech demonstration, which is when we hopefully get something demonstrated in the relevant environment. In all of this entire technology, we call it the technology pipeline. Throughout the entire technology pipeline, we engage as much as we can with partners outside of NASA, both because we don't have the workforce that we used to have, and we don't have the budget to do all the things that we really are tasked to do. And so within early stage, we have our NIAC program, which is NASA Innovative Advanced Concepts, which is literally a program that looks at whether or not, we're not even sure the physics works yet on the technology being proposed, but part of that program requires that you also show how an architecture could be devised in such a way that it would be worth advancing that technology from the very, very low TRL all the way up to advancing beyond what we're currently paying for. What's the change in it? We have our Space Technology Research Grants program, which we put out grants all the time for PhD, for postdocs, for PhD students, for institutions and students fellowships. And again, those are kind of research, low technology readiness level activities. We also manage the Small Business Innovative Research Program for all of NASA out of my organization. And it's on the order of $200 million a year with the objective of advancing new technologies that also meet the objective of building business within the technology areas that NASA is most interested in to meet our objectives, and also develop an industrial base within the nation. As we progress, our game-changing technology program looks at the mid-TRL, and then we have several of the demonstration missions where we use we have a couple that allow a platform, like flight opportunities. You can flight demonstrate in a suborbital flight demonstration opportunity, any of your technologies on some payloads onto these suborbital payload systems. And we have a small spacecraft technology program, which is about using CubeSats to demonstrate different technologies in the space environment. And so all of these programs that I'm talking about have synopses and opportunities for anybody to propose to be a part of and obtain funding from NASA in order to get your technology moved forward to a point of being able to be available for utilization on NASA missions. Our technology demonstrations mission, very similarly, This is the one at the high TRL where we are flight demonstrating. For example, we're going to be launching a mission where we have a deep space optical communication system. We are doing ground testing of cryogenic fluid management for human exploration missions. We're doing electric propulsion that's going to go on the Gateway that will be orbiting the moon for our human architecture. And so, and again, we're very much in partnership with a lot of industrial partners, not just the big players, but also a lot of the emerging space technology areas or businesses. And so the point of what Space Technology Mission Directorate is really about is developing those technologies before they're necessary to make a mission occur off of the critical path of trying to meet a launch date, and then with the hopes that we can actually create new ways that will get us more quickly or more effectively or more safely to our objectives and our grand challenges for either deep space science missions or for human exploration missions for the agency. The other dimension that is very important within my mission directorate is the commercialization aspect, which is helping younger companies or nascent creative, intelligent people, whether they're associated with the university, starting up their own small business, or if they're part of a larger business under IRAD. We're co-investing with them to develop technologies and demonstrate them, and hopefully with the hopes that we can change the game and can do our missions much more effectively, much cheaper, with a lot less funding needed to be funded by the taxpayers. And so overall, that's largely what we do. We have a website where anybody is welcome to take a look at. We are constantly running solicitations. We are constantly looking for people to make proposals. A lot of the gentlemen at the front table here, our chief technologists, spend a lot of time reviewing proposals for each of these different solicitations. And we make awards throughout the year. And so, like I said, this year our budget's close to $1 billion. Not all of that is competed dollars, but it's a lot of money and there's a lot of opportunity. And at NASA, we know that we're not going to come up with the best ideas on our own anymore. And we need to partner with the creative people across the nation and throughout the world who can help us achieve our very difficult NASA objectives. One other thing we do, I forgot to mention it, is prizes and challenges. We do a lot of crowdsourcing. And so we actually had a gentleman who was a stay-at-home dad who won $100,000 because he came up with a way to get our bipod robot to achieve 3 different things that we had set up. So anyone, he was like watching his 2-year-old toddler and like, you know, writing code. So everybody can play, and we don't, and that saves us money in the long run. We can develop a whole lot of capability for this agency by leveraging the people who are much smarter than the ones who have been working on it for 30 years, like myself, and who are inching forward. You guys can leap forward with us. You can bring us with you so that we don't have to bear the brunt of the entire cost. So thanks again, and I think my 15 minutes is up, and hopefully the judges will be back shortly. So no, I can keep going, right? Sorry, I thought your hand signaling was something else. Sounds like the judges are probably duking it out. It does look like our judges are returning, and I imagine the longer that I talk, the longer you have to wait. So I'm going to wrap it up because I know you guys would rather listen to them. So thanks again, everyone, and congratulations again to everyone who made it to this level, and I wish you all the best of luck. A lot of really cool technologies that I can see benefiting NASA in everything that was presented today. So again, thanks so much for your time and energy, and I look forward to hearing what you're looking forward to hear.
Thank you, Therese. Give her one more round of applause for flying all the way out here. It's always difficult. Where's Peter? So Peter's going to kind of go through the top 3, and he wants to talk about the benefits and maybe some other stuff. I don't know.
Well, thank you. Can I have all the presenters over on the side of the stage? All of them? Okay, why don't we have them all come up on stage, please? And big round of applause for all these great innovators. All right, so I want to thank you all to coming to NASA's Ignite Tonight. We've been doing a few of these forums over the past 24 months, and they've been really, really successful. As you heard through the numbers from Kira, over our first few rounds, we've been generating about $368 million for these innovators. Now, this success is just beginning to roll and to continue to develop faster and faster. I know this class, all of them, have potential to be very applicable to space flight as we explore further away from moon and go further. This class, all of them offer something that we're interested in and people around the table are interested in for NASA. But I think you all recognize that there's applications on the ground. I think every one of these has very significant market potential. There's a lot of development. There's a lot of maturity of the idea and the people and the teams. So it really made it difficult for our team to down select from this top 10 to the top 3. And at this moment, I'd like to announce the top 3 to come forward and step to the front of the stage. And from there, I'm going to talk a bit about these top 3 and tell you what our selection was for the top 1 for the top billet. First of all, I want the ARIS team to come forward, please. This was a technology that has a lot of promise both on the ground and in space. I acknowledge that it has stuff both for medical use and also for other systems work that we're very interested in. This is a technology we think is going to go a long way, and we're looking forward to see how we could use this as we evaluate astronaut and human health, system health, as we venture further away from this planet. The second team I want to come forward is Enduralock. This is another great technology, represents a new way, a novel way that we could connect components, devices, systems together. As you know that when we make our systems, they're very complex. Sometimes we need to put them together and transport them someplace. These connections had to be very secure, had to be very durable. But we spend a lot of time when we move things or we test things, and we want to be able to reconnect them securely. We want to be able to take them apart and know that always works. We think this technology, Enduralock, has a lot of potential both in space and our ground systems that is really far-reaching. And we're looking forward to the success for this technology further. Thank you. So stay here. And the final one is the technology of Ubiquity. Now, it should state that Ubiquity is also recognized yesterday at South by Southwest as one of these great startup companies. We share that enthusiasm for this technology. We love the fact that it's a novel technology to get the right wavelengths and to be able to possibly accelerate the production of food as we go into space over the next generations. Because as was just announced today by our administrator, Bridenstine, we are making a commitment for the nation. We are making a commitment for all mankind to learn to live and operate off this planet. We have a very robust budget starting that was just proposed today by the president, $20.5 billion, so we can make this movement away from the earth. We believe it's technologies like this for agriculture in space so that we could grow our produce and develop it on foreign bodies, including planetary systems, that this quantum technology is going to have a lot of dividends. We look forward to possibly using this. So I'll tell you, we went up and deliberated. We had pros and cons for all of these. We thought that we came up with our top 3. It is a very difficult decision. And I want to say that every one of you are winners in my book, the top 10. But when all said and done, we have the top winner. Oh, okay, tell me. Yeah, I'm sorry.
People that are changing the world. We just get to be a small part of that. Yeah. And so they're the ones that are the real rock stars here.
I agree. All of you guys are rock stars. We're going to be working with all of you guys to make you successful. We're particularly showcasing these 3 because you guys have a lot of potential that we want to harvest really quickly. So, very difficult decision. I think all 10 of these teams are winners. The top 3 are super winners, but the top billing that we are going to recognize is Eris MD. So this technology uses conventional MRI technology to be able to deconstruct the relative positioning and location of objects or subsystems in various surroundings for AR and VR purposes. But we really like the idea of the medical application in space, that we can really quickly deconstruct and understand all the subcomponents, the arteries, the tissue, the cartilage, so we can understand if there's damage to a human body, that we could repair it really quickly. We also see that this could be very applicable to systems and be able to decompose, deconstruct systems, and you can use imagination how ubiquitous that could be. So with that, I'm proud to offer this top award for this year's Light That Night Ignite, and we have an award. We have another award for this. Thank you.
Congratulations, Eris. I'm pleased to award you a ticket to the Global Entrepreneurship Summit in the Netherlands. This is an all expenses paid trip. You'll be representing the United States along with 1,200 entrepreneurs from over 170 countries. So congratulations. I hope you'll come to our event later today at 5. Anybody here is welcome to come. It's at the New Dutch Wave starting at 5 o'clock. White House Deputy Chief Technology Officer will be there. I'm sure he'll want to meet with you. And for all the entrepreneurs here, you can still apply to come to the Global Entrepreneurship Summit. It's a competitive application process, and applications are open through March 22nd. So go ahead and put in an application, and we'll be selecting the 400 top entrepreneurs from across the U.S. to attend. So congratulations and thank you.
Can I give this to you guys? So I want to thank everybody for coming out today. We do have a reception from 5 to 6 right over here, I guess. Yep. It starts now. Beer and wine. I don't know. So you might want to join. But thank you for your participation. Thank you for all the judges for being here, and for the entrepreneurs. You guys are amazing, and I hope to see some of you guys at our forum in California. So one more round of applause for these guys. Thank you, guys. Thank you. You guys have a great time.